Hey guys, in this video we're going to add and subtract radical expressions with variables involved. Alright, here it is. So I'm going to assume that you are pretty confident in your ability to simplify a radical expression involving variables. And these are sort of just one step beyond that. So this is a very similar concept to combining like terms. So for example, if I asked you what 2x plus 3x was, you would tell me that's 5x, because since the variables match here in the two terms, I can just go ahead and combine the coefficients 2 and 3 by adding them. And so 2x's plus 3x's would give me 5x's. So this is a very similar concept, except what we need is this radical portion of one of the expressions to match the radical portion of the other expression so that we can combine the coefficients. So as you can see, root 3 is not the same thing as root 27x squared. So if we can get them to match, then we can combine them. So how do we do that? Well, we simplify the radical expressions independently. And so this expression here is actually fully simplified already. So I'm going to leave that one be, and I'm just going to simplify this one down here. So I really like making these factor trees. So as we know, radicals distribute across multiplication. So I can express root 27x squared as root 27 times root x squared. And then root x squared is simply just x. And then root 27, the largest perfect square that goes into 27 is 9. So I can factor root 27 into root 9 times root 3. And then root 9 is of course 3. And so I can rewrite this expression here as 3x times root 3, and then I have my plus 2x root 3. Alright, and now as you can see, I have matching, the radicals match. I have root 3 and root 3 in both of my expressions, so now I can just go ahead and add, I can combine the coefficients. So 3x root 3 plus 2x root 3 would be 5x root 3. Okay, so do a couple more here. So again, the goal is to get these radicals to match. They clearly do not. But in this case, I can simplify both of the expressions and not just one of them. So I'll do one at a time. So I'm going to make a factor tree for this radical portion here. So that's going to be root 2 times root x to the 4th. And root 2 is as good as it gets, so I'll leave that. And then the root x to the 4th is x squared, because x squared times x squared is x to the 4th. Okay. And so before I move on to this one, I'll just write down the simplified version of this. So now, remember, we had an x out in front. So I had an x times root 2 times x squared. So I can multiply the x and the x squared together to get x to the 3rd. Okay, and then I have my root 2. All right, and now I'll go ahead and simplify this radical here. So that's going to be root 18 times root x to the 6th. Root 18 factors to root 9 and root 2. And root 9 is just 3. Okay, and then the square root of x to the 6th is x to the 3rd, because x to the 3rd times x to the 3rd is x to the 6th. And now I have my minus 2 here, so I'm going to be subtracting. And now I have 2 times 3, which is 6, times x to the third, so that's 6x to the third, and then I have my root 2. Okay, and now as you can see my radicals match, which is a good thing, and so I can just go ahead and combine the coefficients. So x to the third minus 6x to the third would be negative 5x to the third, and we have a root 2. All right, we can do one more. So this one's a little bit more tricky than the other two, and you'll see why in a second. So same process, I'll go ahead and work on this radical first. So that's going to be root 90 times root x to the fifth. And root 90, the largest perfect square that goes into 90 is 9. Okay, root 9 is simply 3, and then root 10 is as simplified as that gets, so I'll leave those. Now this is where it gets a little bit tricky, because we don't know the square root of x to the fifth, but I do know the square root of x to the fourth. So I'm going to factor the square root of x to the fifth to the square root of x to the fourth times the square root of x, because x to the fourth times x gives me x to the fifth. So I just factored the square root of x to the fifth here. And now I do know what the square root of x to the fourth is. That's x squared. Okay, and root x is as simplified as that gets. All right, so again, before I work on this one, I'll go ahead and write what I have here. So all the things without a radical will go out front. So I have negative x times 3 times x squared. So that's going to be a negative 3x to the third. Okay, 3, negative x, and x squared. All multiply together is negative 3x to the third. And now everything with a radical will go underneath the radical. So we have root 10x. Okay, so now I'm going to work on this one here. So this will factor into root 10 and root x to the third. And similarly to what happened here, I don't know what the square root of x to the third is, but I do know what the square root of x squared is. So I will factor the square root of x to the third into the square root of x squared times the square root of x, because x squared times x gives me x to the third. And then the square root of x squared is simply x. So again, everything without a radical, in that case I have my negative x squared out front times x. So it's going to be minus x to the third. And then everything that does have a radical will go underneath. Okay, and so we have negative 3x to the third times root 10x minus x to the third times root 10x. So again, my radicals match, which is good, which means I can just combine my coefficients. And so negative 3x to the third minus x to the third is negative 4x to the third, with my root 10x attached. All right, and with that said, it's been demonstrated.